Now here we're applying Snell's law in the context of critical angle and total internal refraction and reflection. So in this case, we've been given a critical angle. So the critical angle here is 45 degrees for substance that's surrounded by air. And we need to determine the refractive index from air to the substance. So if you're first looking at our case, if I do a little sketch again, so if we've got our substance that is located here, and we've got air, which is on this side. What we now have is the incident ray hitting the boundary, coming from the substance side, hitting this under an angle, which is the angle of incidence, which is this critical angle. And it's going to leave it, in the case that it's just the critical angle, going to leave it so that that is 90 degrees. That's the definition for the critical angle. So if you have this set up and you're now placing this in your equation, you've got sine of I over sine of the refracted index. That's going to be 1 because R is 90 degrees, sine of R is 1. So that's going to be the refractive index from the substance to air. So substance to air. So sine I equals, in the end, n substance to air. But we want to know the refractive index from air to substance. Remember again, switching these indexes, meaning inversing this, so it then becomes n a air to substance. Bearing in mind that we want to calculate this refractive index, now it's just a matter of inverting it on both sides, and we've got the refractive index from air to substance being 1 over sine of I, which in this case is 1 over sine of 45 degrees, which in this case gives us a value which is 1.4. So now we've got the refractive index from the air to the substance, 1.4, after knowing what the critical angle is.